Venn. So we are dealing with a beautiful topic called as sets. So before going to the set, we need to know whatever the surroundings we are collecting one by one or each day or every day. So when it comes to boys and girls, so boys have the craziness to collect the card collections, bike collections and everything. When it comes to girls, we usually, as usual, the jhumkas, the sets, as we daily processing will be collecting these materials. So how it is related to this topic, let us see. So while covering this set chapter, we will be moving through different terms, different conditions and different methods also. So the first thing, we need to know what is the definition of a set. The second thing, how many methods are using to define the sets. So the methods of sets are roster method and set builder method. And when it comes to the types of sets, we have many different kinds of sets. So we'll be learning particular sets also. So then the last thing is operation of a sets, which is very important here. Compulsory 5 marks and 3 marks problem will be asked. When the next one is complement of a set, and the last very important is Venn diagram. So let us know what is a set. So when it comes to a set, we usually say that it is a collection of a well-defined objects. So how we define a set? So set is a collection of well-defined objects. So how can we say that it is a well-defined? Let us see. So rivers of India. How many rivers of India are there? So many things. One is Ganga, Brahmaputra, Yamuna, and so many others. We are listing one by one. So that is the collection of India where the rivers are flowing, that is called as a set. It is well defined. Rivers of India. Next, set of natural numbers. Obviously we can do. So when it goes to set of natural numbers, so the natural number starts from 1, 2, 3, 4 up to so on. It will be going on. Next, set of integers. So before going to the set of integers, we have to know what is an integer. Obviously, the negative numbers as well as the positive numbers, including zeros, will be included. So then set of integers will carry from negative numbers, that is -3, -2, -1, and including 0 again 1, 2, 3 up to so on will be included. So these are the definition of a set, and you have come to know how to write a set also. Then how do you represent the set? Representation of a set is very important. So, in representing of a set, there are 3 major terms you need to understand. One is, when you are representing any kind of set, it should be under capital letters. What it should be? It should be under a capital letters. Then, elements of the set should be written in a small letters. For example, let us take a small example here. Let A be the set containing the set of natural numbers, first 10 natural numbers, that is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. The first 10 natural numbers, the elements is called as, for the given set, you are representing the whole elements should be in a small letters. If there is a letter form, you can write it in a small letters. When there is a numeric form, directly you can write a letters form. Then, when you are representing any kind of set, it should be marked with a flower bracket. So, why it is a flower bracket means for every time when you are defining the set should belong to this set, the given set or not. So, that's why we have to mention the flower bracket. It is very compulsory. So, this is how you see the representation of a set. So, this completes the one topic. So, what is the first topic we learned here? The first topic was definition of the set is completed. have two methods are there. One is roster method and another one is set builder method. So when it is a roster method, you can around say write it as for any given of a set, you have to write it in a listed format. For example, let us say, so roster method, all the elements of a set is in a list format. So it should be under a list format. That is, let us say, set of all natural number divided by 42. Set of all natural number divided by 42. First find out what are the factors of 42. So 42 has, so it is divisible by 1, again 2, again it is divisible by 3, again it is divisible by 6, it is divisible by 8, sorry, it is divisible by 7, again it is divisible by 12, it is divisible by 42 itself. So these are the factors of 42. Now how can I list them? Let us take any kind of set. Yes. So write the factors on the set. So how many factors are there? First one is 1, 2, 3, 6, 7, 12 and 42. So the listing of the elements is called a roster method. So next comes to the set builder method. So when it comes to the set builder method is whatever the listed form that have been given, you need to explore in a statement format. For example, see what is the statement that have been given? All the elements of a set with a common property or in a statement format. The statement format, what you will be analyzing the given example that has to be written in a statement format. Let us take an example here. They have been given A, E, I, O, U is a set. As you know, A, E, I, O, U is nothing but vowels of English alphabet. So when it comes to the vowels of English alphabet, then how can I represent it in a set builder form? It is very simple. Let us take a set A. Let us take a set A, so which is equal to, as I previously told, when you are defining any kind of set, it should be in a flower bracket X such that X is a set of vowel. So this is how you represent an statement format. Let us take another one. When it comes to alphabet, it is easy to verify. When it comes to a numeric wise, it is very different. So when you are defining each and everything, you have to be very careful. So here they have been given the set A is equal to 1, 4, 9, 16, 25. By analyzing this, you can say that the given set of numbers is in the formation of squares. Is in the formation of squares of each number. So that is 1 square will give the value 1, 2 square will give the value 4, 3 square will give the value of 9, 4 square is giving the value 16. Like this it will be going on. So how can I represent it in a statement format? Very simple. So that is A is a set which is equal to X such that X is equals to N square. X is equals to N square is nothing but where you have to define this N. N belongs to natural numbers. N belongs to the natural numbers. This is how you define a methods of sets. When it comes to, so we completed two topics now. One is representation of a set, another one is methods of set, and the last, the final major thing is types of set. So when it comes to types of set, by the heading or steps only we can say that finite set, infinite set, equal set and void set. So let us go a little bit back, so it is very easy to remember these things. So when it comes to types of set, the first thing is types of set. The major thing is we define here void set or empty set. Empty set, or it is also called as null set. It is also called as a null set. So it already says that void set, empty set, null set. Very simple. So when the set containing zero elements, then it is called as a null set. For example, let us take a set B is equal to a null set. Set B is equal to null set. Let us take one more. C is equal to X such that set of natural numbers where X lies between 3 and 4. Is it possible? The set of natural numbers which lies between 3 and 4? No, it is not possible. So C is again a null set. Next, set of sides measure. Is it possible to measure the side? No. Is it possible to count your hairs? No. All these are it is very large thing. It is uncountable. So we usually define it as infinite set. Infinite set. That is the set of element which is not countable. Then it is infinite. For example, set of all natural numbers. Is it possible to count? No. It starts from 1, it goes on. There is no end to it. So, next, set of even numbers. Set of even number in natural number. Is it possible? This is also not possible. So when it comes to even natural numbers, everything is divided by 2. Then it is a even natural numbers. Even though the natural number is also a not countable one, then how can this be countable? So it is also a non-infinite set. Then which is a finite set? Finite set which is countable. Finite set, the set of those elements which are countable. Then it is a countable. Then it is a finite set. For example, let us take A is equal to set of natural numbers from 1 is less than, x is less than or equal to 10. Yes, 1 to 10 it is countable. Next, let us take another set. B is the set of vowels. Yes, it is also countable. A, E, I, O, U, it is also countable. So like this, when we group point on any kind of given set which is countable and which is not countable, then we can usually define what is a finite set and what is an infinite set. The next set is your equal set. The next set is your equal set. So equal set, it also obviously says that when they have been given two sets, both the sets should be having the same number of elements and same number of elements of a given thing. That is an equal set. Let us take, for example, let A be the set. Let us take one example. that is AB the set which is equal to 3, 4, 1, 2, and B is the set which is contained 1, 2, 3 and 4. Then how can you say these both are equal? The same number of elements should be present in another set also. Then it is an equal set. A is equal to B. This is called as equal set.